I'm Andy Jones. I'm a distinguished analyst with the Information Security Forum. We're a cybersecurity research organisation funded by about 480 now global organisations, and we've recently put out some stuff on ICS, IoT, and supply chain. So why am I here talking about shipping? Because my last job was the Chief Information Security Officer for Maersk Line, the biggest shipping line in the world. And that is where many of my exposures to IoT have actually come from. So I want to just, within about 15 minutes, give you quite a lightning view of what IoT looks like in the maritime. Some of the challenges for maritime, they're not necessarily unique for maritime, but maritime has its own characteristics. And I want to establish it's not that long ago that being at deep sea meant completely out of contact with everyone. There was no means of getting in contact. You were lost to the world. And in maybe the last 10 years, that's changed. So across the oceans now, we have consistent, relatively high speed, reliable satellite coverage. So that means suddenly maritime has gone from being an old industry to being an industry that is desperate to digitize. It is, if you look at comparable industries such as aviation, shipping is about 20 years behind because it hasn't had the means, it hasn't had the connectivity to digitize. Now it's connected, and it very much wants to digitize. And that's reflected in taking maritime online, and the IoT plays a big place in this. So if you look at something like a Purdue diagram, you can see this is the same as a floating factory. You have things down the bottom here, you have your propulsion, you have your rudder systems, you have your anchoring system. They're ICS enabled. You've got SCADA systems sitting on the ship. It's a big floating factory. And on top of that, you have the admin layer, the thing that pays the payroll, that does the thing for the documentation to get into ports. And what we've done, we stuck a satellite dish on the side. And we suddenly enabled this 30-year-old infrastructure very, very quickly. And it's not just in the shipping line. If you look at the shipping line and particularly bulk carriers, yes, we've done that there. But think of the cruise lines. Think of the floating hotel, the 1,000-bed floating hotel full of 5,000 people all looking for retail opportunities. The digitization possibilities are endless. So really, maritime has embraced this world very, very quickly. Some of the use cases I'll talk about, just to give you a flavour of what it looks like. I'm going to talk about the first one probably more extensively because that's the one I'm most familiar with. This is remote container management. Now, if you look at a big container ship, and you all know what a container looks like because you get stuck behind it on the motorway, a big ship will take about 9,000 to 10,000 of those and take it all the way around the world, down to China. And if you look at a ship for the Maersk ship, certainly you'll see a combination of different colours and white ones. The white ones are reefers. Now, reefers do not refer to drugs. It means refrigerated, right? So that's where your ice cream goes. Technically not ice cream, but it's things like frozen prawns. Frozen potato is a big cargo that goes in it. And these things have to stay frozen or chilled, deep chilled, for months. Through tropics, through a force 9 gale. It's really, really hard. And on a typical ship, which only has a crew of about 15 to 20, there was an electrical engineer. Now, his job was to go round these 2,000 containers on the ship of 10,000 and make sure they weren't getting too warm. Right? It's not a great job in a force 9 gale. So what we thought as Maersk, we thought, let's make this person's life a bit easier, and we can do something clever with mobile phone technology so he can have a screen in his cabin and he can go and mend the ones that are getting too hot. So we'll put a temperature sensor in them. So we did that. We thought, well, that's pretty cool. That's good for the electrical engineer, but there's some interesting stuff here. Can we get it back to our head office? So we looked at a ship and we looked at that thing and said, what's the thing that looks like a satellite dish? It's a satellite dish. Let's use that. So we squirted the data back to the head office and started to get a picture of the 600 fleet. And we started to be able to do clever things, like we could change the temperature of a container remotely at sea. So if it was getting too warm, we could turn it down. And then we thought, well, would customers pay for that information? So if you've got your frozen prawns, you want to be very clear that your frozen prawns have stayed frozen all the way across the world. If you've got some bananas, you actually might want to stop your bananas from ripening so much. So you want to actually change the temperature and humidity of these containers at deep sea. And that was pretty unique. And this is now being employed by other container manufacturers, but gives something that started off to make an electrical engineer's life a bit easier, a really interesting and money-generating avenue through IoT. So it's all IoT enabled, but of course, it connects the ship. And that's where I started to think, well, has that created some other threats to it? Some other interesting things going on. This is a Japanese shipping line. They're just using the IoT to put sensors in ships, vibration sensors. So what they do, they actually put, when they build a ship, they put vibration sensors through it, and they just monitor that as an IoT installation to see where you get problems with loadings, because ships can actually break apart at sea if you're not careful. So it's very important to understand where you've got an area of vibration, where this has come out of the true. So they can do that remotely on their shipping fleet. So they can prototype new designs and actually do a lot of research work and actually take out the noise from a ship. And that's important in things like cruise ships. You don't want to be in a cruise ship and hear a banging all the time. That makes you a little bit worried. So that's an interesting use of the IoT. Probably the most interesting thing for me is the use of the IoT in propulsion and pollution. So this is a typical engine from a big ship. They're really big. And in terms of the consumption of oil, or bunker as we should call it, this is the biggest cost for a shipping line. So if you can put in flow meters, IoT enable them, squirt all that data back to your head office, then suddenly you've got a real-time picture of your fleet of 600 ships, and you can manage it proactively. You can say, hey, slow down a bit, take a different route, and start proactively managing your bunker through your fleet of 600 ships. And that really has a lot of cost advantages. One of the other elements that's coming that I see IoT being important for now is sulfur dioxide. Ships are actually quite big polluters. No doubt about it. And there's a lot of impetus now to go to sulfur reduction in the bunker, so there's less pollution. So IoT will be monitoring, and there may well be a regulatory angle to that. So you actually have to prove that you're reducing your sulfur dioxide through the use of IoT. So lots of use cases on ships, really interesting. And lots of places we could use them. We've talked about cargo, preventative maintenance. So the engine knows it's going to wear out, so it can automatically order its own parts. Navigation improvements, bunkers we've talked about. Autonomous vessels, we haven't. That's an interesting area. I'm not actually a big believer in autonomous vessels, but there's definitely work going on. Maersk did actually put one together, but we didn't go anywhere with it. But things for customer engagement. You know, if you've got 5,000 people who are prepared to pay for bandwidth, or actually want to use shopping opportunities on a cruise liner, which is just a big floating shop, lots of things you can do with them. But that brings new risks. So piracy is still a big problem. Physical piracy is a big problem for shipping. But what does cyber piracy look like? So to be a pirate is a high-risk activity. You need to get a boat, put a big engine on it, get some guns, get some friends, and travel 200 miles into the open sea and try and board a moving vessel. Right, that's quite dangerous. Can you have a similar effect by spoofing some of the navigation and make the ship think it's somewhere else and actually get the ship to come to you? Can you then disable the ship from the shore by attacking it through its connected IoT devices and then board it yourself? That's a lower risk occupation. Is a ship vulnerable to hack? Ships have a life of 30 to 40 years. The machinery on them is old. The protocols are old, and we put shims and skims around them to make it all work, but now we've connected it, and it was never designed like that. So can we actually do some hacking with the ship? Can we use extortion? Can we plant ransomware on the ship and say, well, you want your ship back? Give me some money. And what does malware look like in an industrial control environment? Because we've now got a connected infrastructure. And a lot of targets to choose from. I've talked about some of the IoT case studies. There will be more, but there's industrial controls on the ships. There's GPS, there's electronic maps, there's positioning systems, eminently spoofable, lots of satellite connectivity, and a lot of third parties involved in shipping. And of course, people. And it's a bit hackneyed, but the weakest link is to security is people. There are a lot of them on a cruise ship. So interesting areas to look at. And I've talked about connectivity, and the problem with industrial controls is not that they don't work, but they are very trusting. So here's a rudder for a ship, and it is expecting to have a command from the helm, and it's all moved by actuators. It's an industrial control environment, and it's expecting to actually receive a command from the helm to turn the rudder. And if it sees this set of text here, that's actually a 10 degrees to the right turn. It'll move the rudder 10 degrees to the right. It doesn't check to see where that message came from. Why would it? It's at sea. Now, that's true in the old days, but now we've got a connected ship that's exposed to the internet. Is there a possibility this could come from somewhere else? If that said L, it would turn the rudder left. Now, the thing on the right is a check digit, but you can work out how that is. That's industrial controls. That's how it works. These environments are very trusting. This is 100,000 metric tons of dead weight. That will kill you. That's the difference. But also some interesting behavioural issues. So if you're going crew on a container ship, there are about 15 to 20 other people you've probably never met. Most of them are contract crew, speaking many different languages. You've got 3 months at sea. It's dull. What are you going to do? You're going to bring your Facebook, you're going to get everything, you're going to get online, connect to your family, watch your pirate movies. It's a hostile environment. And it's a very lonely environment. And crew are actually quite prone to things like phishing attacks. It's a very lonely environment after 2 months at deep sea. So they are actually very susceptible. There's a lot of work going on about the people issue and the people influence in now what is now a connected vessel. It never used to be like this. They used to go and sing sea shanties in the bar. They don't. After their shift, they'll go back to the cabin, put on Facebook. It's changed fairly recently. And of course, there's your attack surface. Lots of stuff to play with. A lot of it is already connected. More and more will become connected. It's a large attack surface to choose from. It uses satellite connectivity. As it gets into shore, it starts to use 4G, starts to use Wi-Fi. And of course, the crew will start to pick up a Wi-Fi tool. So as it comes into shore, it gets even more connected and even more outside of your control. So these are what ships look like nowadays. So have we created a perfect storm? Is this what a sort of diagram of the ship looks like? Have you got the systems that are connected to each other, that are exposed to the internet, that are cross-connected, that have lost their ICS air gap? Pretty much. This is how they are. Ships are hostile environments. You've put an electrical engineer on board. If they're a bit bored, they want to make their life easy, yeah, they're going to change the connections. They're going to change your network topology. That's what they do. So maybe it's a perfect storm. But an important storm. So 90% of manufactured goods travel by ship. That's a fact. Maybe they don't need to. Some of it's just plastic rubbish. But most of it goes on a ship. And this is world trade. World trade is shipping. And also has a military connotations. If you look, most navies or armies will use hired commercial shipping to do their heavy lifting for us. How do you get the tanks to Iraq? You borrow a Maersk ship and put them on. The US Navy don't have that capability. So it's actually often a target. And as we weaponize cyber, shipping comes into that line of sight. And, for some economies, it keeps them going. They can't survive without shipping. It is critical infrastructure. It does come under the NIST directive now. So there's a lot of attention being made on this perfect storm that we've created. We have regulators, of course. This is the IMO, which is a regulator. And of course, we have an environment that's safety critical. It has these good practices in things like safety, but it also has some interesting other practices like legacy and a long lifetime, a 50-year lifetime. And we have these strange concepts of ships being flagged in different states where they have different regulations. So a lot of mix of regulations. And we have the shipbuilder problem, that the ship operator didn't build the ship. The ship was probably built in 2 or 3 different shipyards. And no one ship looks the same as the other. It's really hard to secure it because they all look a bit different, because they're all built different. So drawing it together, so the IoT in the maritime environment, this is an environment that's become connected very, very quickly and relatively recently, and it desperately wants to digitize, and it will digitize, and there are all sorts of advantages in doing so. But it is an old, legacy, hostile environment that can certainly move and kill you that we're connecting. So we just need to be a little bit careful to this. Certainly this is accelerating through it, and what we're seeing, of course, where we're seeing everything else, regulators are worried about critical infrastructure. So we've started to see now regulations for the IMO that actually say every ship should be assessed for cyber security health before it sets sail. That's quite a big ask, and it's because they're worried, and we're moving towards that. So, bumpy ride for shipping, batten down the hatches, and that's a bit about maritime. Thanks very much.